Hello, algebra students. Today we're going to take a look at GCF and LCM with a factor tree. So the greatest common factor of the GCF is going to be the greatest or mathematically largest integer that is a factor, so can divide into two or more given integers. Let's get rid of that or there. And then the greatest monomial factor, the monomial piece, is just that it could contain variables. And so it's a common factor with the greatest coefficient and before we go any further, let's make sure we're kind of thinking about what that is. That is a number being multiplied by a variable. So hopefully you're familiar with that term, but just as a reminder. So the greatest common monomial factor will have the greatest coefficient and the greatest degree of the variable. And so that is the highest variable power. And hopefully you'll notice that kind of coming up as we go through with GCF. And LCM, least common multiple, you have the lowest product possible, or the least product. So that is going to be those multiplied together between two or more factors. So greatest common factor, you're looking at kind of the matching building blocks, and least common multiple, you're looking for the lowest product that you multiply to. And hopefully we'll kind of compare and contrast those as we go through. Now, one way to find GCF and LCM is to break the monomial down to its building blocks or its prime factors with a factor tree. Now, it's not the only way to find GCF and LCM, but it's pretty effective especially when you're working with large variable values and algebraic values. So that's the way we're going to use. So to find the greatest common factor of 6s squared t squared and the value 9s t to the third, I'm going to show you the factor tree method. So we do want to break down those values into their prime factors. So we'll start with 6s squared t squared and just doing the factor tree for that. So we're going to break down the coefficient of 6 first into its primes of 2 times 3. And then the letters just break down to how many there are. So that s squared would be s times s, and t squared would be t times t. And then we have the second value, and that second value we want to break down is 9s t to the third. Now again, for the coefficient, we're going to break it down into its primes, which is 3 times 3. And then there's one factor of s and 3 factors of t. Now, as you get better at this, you might not have to break them down every single time, or you start to break them down easier. And you don't necessarily have to write the letters out, like t times t times t. You could just write t to the third, but you just want to be aware that they're made of those building blocks. Because for GCF, you're looking at what they have in common, what matches. And for GCF, you look at what is in common between them. They both have a factor of 3. So I'm going to write down a 3 for GCF times. And they both have a factor of s. And so I'm going to write down a factor of s. They both have 2 t's. So I would write down 2 factors of t. And then to find the GCF, you just multiply what they have that matches all together. So that would be 3st squared. So the greatest common factor between those two monomials is 3st squared. It's the biggest factor that would divide into both of those. So our next step is to find the least common multiple of those two monomials. And so again, I'm going to approach it with a factor tree. Now we've just done the factor trees for these, but just to take you through those steps. So we would break down 6s squared t squared into its prime factors, which same as before, 2 times 3, and then 2 factors of s and 2 factors of t. And we break down 9s t cubed into its primes, and that's a 3 times 3, 1 factor of s, and 3 factors of t. Now the least common multiple is a product that has to contain both of the starting values. So it has to have the building blocks of each. And if you would happen to be finding the LCM of more than 2 values, it would have to contain the building blocks of all of them. So if it needs to contain the building blocks of all of them, I know it has to have the building blocks of the first value. So I need a factor of 2, a factor of 3, 2 factors of s, and 2 factors of t. So the first value, 6s squared t squared, is found inside of the final value. But I know it also has to contain the factors or the building blocks of the second value. So I want to look at the second value. There is already one factor of 3, but I need another one. So I'm going to put down another factor of 3. So the final LCM will have 2 factors of 3 in it because the 9 has 2 factors of 3 in it. It already has 1 factor of s, so I'm good on s's. And I have 2 factors of t, but I need another one. So in my LCM, I need to put in another factor of t so that I have the building blocks of all of them. I have a 2, a 3, 2 s's and 2 t's. I have 2 3's, an s, and 3 t's. It's just kind of going through that list of all the factors. Then I multiply them together. And so I'm multiplying 2 times 3 times 3. So 2 times 3 gives me 6. 6 times 3. So we have 2 times 3 is 6, and then 6 times 3 is 18. Then I have 2 s's, or s squared, or s times s, and 3 t's, and that's t to the third. So my LCM is 18 s squared t to the third. Again, for least common multiple, both values have to fit kind of inside your LCM. So we're going to look at the next 2 monomials and find the GCF. Now, remember, GCF is what do they have in common, what matches. And so I'm going to break those down into their primes. So the first monomial, negative 7x y to the third. When now we're breaking down a negative value, we're just going to pull out that negative. So when I break down the negative 7, I'm just going to say negative 1 times, and then of course 7 is prime. But we just pull out that negative 1 factor to kind of get rid of the negativeness of the monomial. Not that that's really a word. Okay, and then we have x, and then we have 3 factors of y. And our next monomial, 14, x squared, y squared. And we break down 14 into its primes, and that would be 2 times 7, 2 factors of x, and 2 factors of y. Now remember, for GCF, you're looking for what matches. Okay, so what they have that matches is they have a 7, and so that goes into my GCF. times, and again, I look for what else matches. They both have a factor of x, and so that goes into my GCF. And they both have 2 factors of y. And so 2 factors of y go into my GCF. And so my greatest common factor is 7xy squared. And that's your GCF. Now to find the LCM of those 2 monomials, again, you would do the factor tree. Now we've just done that. So I've kind of copied over the kind of base of my factor tree. I've just broken it down into the primes. And remember, for the LCM, you want it to contain all the building blocks. So for my LCM, I need the LCM to contain all the parts of the first value. So I'm just going to write down all the parts of the first value. And I need to make sure that the parts, all the building blocks or the primes, the second value are there as well. So I don't yet have a factor of 2, so I need to put that in. I do already have a factor of 7, that's already taken care of. I have 1x, but I would need another one to contain the second value. So I want to put in a second value of x. And I have 2 values of y, and so those are already taken care of. Then I just multiply everything together. So I've got -1 times 7 is -7, times 2 is -14, and then I have 2 factors of x, or x squared, and 3 factors of y, or y to the third. So my LCM is -14 x squared y to the third. Again, it has to be a value that both other values would be able to divide into or be inside of. So we're going to practice a little bit. So we have some more monomials here. We're going to find the GCF of 20ax to the third and 30abx. So let's break them down into our factor trees. So 20ax to the third is going to break down into, I'll just start breaking it down into 2 times 10 times a and 3 factors of x. But 10 is not prime, so I want to break that down even further. So I can break 10 into 2 times 5, and then I have my factors of a and 3 factors of x. Notice that that third power only goes with the x. It does not go with the a, since the a does not have an exponent. It's just 1 factor of a. And then 30 would be 3 times 10, and then I have an a b, and an x. But of course, 10 is not prime, so I want to break that down further into 2 times 5. And I have my a, my b, and my x. Now for GCF, we're looking for what matches between them. And so they both have a factor of 2. And so in my GCF, I would include a factor of 2. They both have a factor of 5. So in my GCF, I'm going to include a factor of 5. They both have a factor of a. So in my GCF, I'll include a factor of a. And they both have a factor of x. So in my GCF, I include a factor of x. And then I just multiply them together. So my greatest common factor is 2 times 5, or 10ax. So for finding LCM of those 2 monomials, again, we want to start with our factor tree. So I've just copied that over from the previous problem, since of course the factor tree would be the same. But then for LCM, remember, we want all the building blocks. Of each. So for LCM, I want to use all the factors of the first value, and then I see what else I need to contain the second value. So I don't yet have a factor of 3, so I need to put that in. So I would put in a factor of 3. I do already have a factor of 2 and a factor of 5 and a factor of A, so I'm good on those. I don't have a factor of B yet in my LCM, so I want to put that in. And I do already have a factor of X, so I'm good on that. Then to find my LCM, I'm just going to multiply it all together. And so I would multiply my 2 times 2, which is 4. And 4 times 5 is 20. And 20 times 3 would give me a coefficient of 60. I have one factor of A, one factor of B, and 3 factors of X. Now, it doesn't really matter what order you write your variables in, but typically, algebraically, the best form is to put them in alphabetical order. And so that's why I wrote ABX to the third. So we're back to GCF for 2 new monomials. So you have 25p squared QR and 36pr to the third. So we want to break those down into their primes. So for 25, I've got, not 2 there, 5 times 5, 2 factors of p, a q, and an r. And for 36, I'm just going to start with 6 times 6. You might start with something else. P on 3 factors of r, but now 6 is not prime, so I can break that down further. So that's 2 times 3, and 2 times 3, and then I have my factor of p and the 3 r's. Now remember, for GCF, what matches? And so for my GCF, I look and I see no numerical coefficients that match in primes, but I see a factor of p that matches, and so that's part of my GCF. And I see a factor of r that matches. And so that's part of my GCF. And that is it for matching. So my GCF for those monomials is just PR. To find the least common multiple of the LCM, I'm still going to break it down into the primes. So I just copied those over from the previous problem. You can copy down your primes. And then remember, for LCM, I want the building blocks of each. So for my LCM, I want all the parts of the first value, and then I want to make sure I have all the parts of the second value. I don't have any of the numerical coefficients, so I know I need to put those all in. And I look, and I do have one factor of p, so I'm good there. And I have one factor of r, so that's good, but I need 2 more. So I need to put in 2 more r's for my LCM. And then for my LCM here, I need to kind of multiply everything together. So I'm going to take my 5 times 5 times 2 times 3 times 2 times 3. Or basically, I'm really multiplying my coefficients of 25 and 36. So I get a coefficient of 900. And then I have 2 factors of p, or p squared. I have 1 factor of q. And I have 3 factors of r, or r cubed, or r to the third. And that is my LCM. So you're going to find a GCF of 4c to the third and 8c. So I'd like you to break it down into its primes and find the GCF. You're going to enter your answer on Edpuzzle, and then the video will continue so that you can check. So for the GCF, you want what matches, and so hopefully you found that they both have two factors of 2 and a factor of C, so the GCF is for C. If you're still struggling with that, make sure you're bringing your questions into class or entering them on Edpuzzle. For the next one, you're going to find the LCM of 4C to the third and 8C. Again, I want you to enter your answer on Edpuzzle, and then the video will restart and you can check. So for LCM, we want the building blocks of the first one, which are 2 times 2 and 3 factors of C. And then to contain 8C, we just need to put in one more factor of 2. And we multiply that together for the LCM. We get 8C to the third as the LCM. Again, if you didn't get that, please make sure you're bringing in your questions to class or you're entering them on Edpuzzle.